The built heritage is an economic asset to Scotland. Last year, it attracted a record-breaking 5 million visitors and contributed over £700 million to the Scottish economy. It's also a cultural asset too, something that people are proud of, not only because our castles and abbeys are beautiful, but they also preserve the rich and diverse history of Scotland throughout the ages. Now, although we think of stone as being hard and durable, it is susceptible to decay, just like any other building material. And unfortunately, over the last decade, Historic Environment Scotland have noticed rapid rates of stone decay at some of their most vulnerable sites, like this one here, Jedburgh Abbey near the Scottish borders. This abbey has stood the test of time. It's over 900 years old, over which time has been subject to Scottish weather, something I'm sure we could all sympathise with in Glasgow. So, what's happening on a microscopic scale? Some stones are very porous, meaning water can penetrate the stone surface and move around using the accessible pore network. Over time, water acts as a catalyst for stone decay, influencing all kinds of mechanical and chemical weathering processes. These processes eventually lead to material loss, which in turn creates a more open porosity, thus creating a vicious cycle where decay becomes faster over time, often to the point of complete ruin. The main problem right now for conservators is that so little is known of these complex interactions between stone and the environment, and why some stones decay differently to others, thus limiting any kind of conservational measures made by industry. And this is where my job as a geologist comes in. My job is to figure out what the stone is made of. My research is focused on characterising the mineralogy and petrophysical properties of these historic stones, using techniques such as high magnification microscopy to identify and understand the processes causing decay at these buildings. It will also be important to consider how stone will respond to climate change. So, for example, Scotland is forecast for wetter, more frequent rainfall events. This may mean more stone-water interactions and subsequently more decay. By understanding these decay processes and how they differ depending on stone geology and environmental conditions, we can then work with industry to identify the best conservational measures for protecting our historic buildings and Scotland's iconic past.